Scientists led by Professor Kerry Saya, based at the Earth Observatory of Singapore, have been diligently analyzing complex data in search of the impact crater left by a massive meteorite that struck the Earth's surface approximately 800,000 years ago. Despite the frustration of not being able to locate the crater for over a century, Professor Saya and his team believe they have finally found the answer to this long-standing mystery. While the exact whereabouts of the crater have eluded scientists, they have been able to ascertain that a large meteorite collided with Earth around 790,000 years ago. Concrete evidence of this impact lies in the remnants left behind, known as tektites. Tektites are formed when a meteorite's powerful blast generates such high temperatures that the Earth's rocks melt and transform into molten liquid. This molten rock is then propelled into the air before cooling and falling back to the ground. The resulting formations, scattered widely upon re-entry, provide crucial clues for scientists to trace and determine their age. By studying the distribution of tektites, researchers can also infer the likely location of the impact. Although the specific location of this massive meteorite's impact has only recently been pinpointed, meteorites and asteroids have been colliding with Earth for millions of years. An asteroid is a large rock orbiting the Sun, while a meteoroid is a smaller rock also revolving around the Sun. When a meteoroid disintegrates in Earth's atmosphere, it is referred to as a meteor or a shooting star. A meteorite, on the other hand, is the portion of a meteoroid or small asteroid that survives and lands on Earth's surface after failing to vaporize completely. The size and composition of a meteorite or asteroid determine the extent of its impact on Earth. For instance, the asteroid or comet believed to have struck 66 million years ago is thought to have led to the extinction of dinosaurs and numerous other species. The resulting crater, known as the Chicxulub crater, measures over 90 miles wide and was discovered in the 1970s during oil exploration in Mexico's Yucatan Peninsula. In the case of the mysterious crater studied by Professor Saya, the meteorite was considerably smaller, estimated to be slightly over a mile in diameter. Nonetheless, its impact caused devastation in the region where it landed. Tektites from the blast were dispersed across the eastern hemisphere, spanning approximately 20% of its surface area. The spread of tektites across the planet is referred to as the Australasian strewn field, representing the area covered by tektites resulting from this meteorite impact. This particular meteorite impact is considered the most significant on Earth within the past million years. In a published paper, Professor Saya and his colleagues described the challenge they faced in locating the crater. They noted that the strewn field's tektites provided vital clues, pointing to a possible location within Indochina, near the northern limit of the strewn field. Although this narrowed down the search area, it still encompassed a vast territory. The tektites had spread across Indochina, reaching from Antarctica to Southeast Asia and extending over the Pacific and Indian Oceans. Tektites have played a crucial role in identifying crater sites. They are distinguishable from volcanic glass-like pebbles through careful chemical analysis and their exceptionally low water content. The term tektite was coined by Austrian geologist Franz Edward Suess, who identified these unique pebbles formed by meteorite impacts. While the word is relatively recent, tektites have been observed for thousands of years. The earliest recorded instance comes from China around 900 BC, when Liu Sun described these peculiar stones, most likely tektites, as mink stones of the thunder gods. The existence of tektites from the meteorite under investigation suggests that the impacting meteorite was of substantial size and velocity, able to melt the rocks it encountered. Despite the evidence gathered from tektites, the precise location of the crater remained elusive until recently. The tektites resulting from a meteorite impact around 790,000 years ago covered a vast area spanning thousands of miles. Although analyzing the spread of tektites can provide clues about the impact's epicenter, the large extent of the tektite field has made it challenging to pinpoint the exact location. Despite expectations that a meteorite over a mile in diameter would create a visible crater, the difficulty lies in factors such as Earth's dynamic surface changes over millennia due to tectonic plate movement, volcanic activity, and seismic events. Southeast Asia, the probable region for the crater, has low rates of surface change, but the search for the crater remained elusive until recently. Professor Kerry Saya and his team have been conducting extensive research to identify the impact crater using various scientific methods. Their latest breakthrough led them to believe that the impact crater is located in Laos, specifically on the Balavan Plateau in the southern part of the country near the Mekong River. The researchers analyzed multiple lines of evidence, including the chemical composition and physical characteristics of the tektites, gravity measurements, and the age of lava flows that could potentially cover the crater. By comparing tektites from the Laos site with those from the broader Australasian strewn field, the researchers found a good match, indicating a common origin. Additionally, analyzing the strength of the gravitational field around the suspected impact site revealed a lower level of gravity consistent with the presence of a crater. The team calculated the dimensions of the oval-shaped crater to be approximately 11 miles in length, 8 miles in width, and about 300 feet deep. Further evidence was uncovered when construction workers accidentally exposed a pile of sandstone boulders near the suspected impact site. These rocks fit together like a jigsaw puzzle and showed signs of shattering upon impact, supporting the theory of an ejected debris field from the crater. Additionally, analysis of quartz grains in the rocks revealed evidence of fracturing, further supporting the presence of a meteorite impact. While the evidence strongly suggests that the researchers have identified the likely location of the long-sought crater, further investigations are necessary to confirm their findings. Drillings will be conducted to examine the rocks below the lava layers and determine if they align with the expected composition of an impact site. Professor Saya remains cautious and refrains from claiming absolute certainty until further exploration is completed. Thanks for watching. Never forget to like, comment, and share the video. And remember to subscribe to the channel and press the bell icon for regular updates.